Newton's method is a way you can find the zeros of a function without using a graphing utility or factoring or any of the other forms of zeros we used before. So for example, x squared minus 6. Now, how you do this is you set up, you have your number, which iteration you're using, and say just 1 and 2 for now. And you have x to the power of n. Then you have f of x to the n. Then you have f prime of x to the n. Next, you have f of x to the n over f prime of x to the n. Finally, you have x to the n minus f of x to the n over f prime of x to the n. All right, so when you're doing this, first you give like a guess. So for example, x1, let's say, is around 2.4. That's our best guess to where the 0 is near. Well, we plug that into our equation. So 2.4 squared minus 6 is negative 0.24. Now we plug that into our derivative, which would just be 2x. 2x. Now, that would be 4.8. Now we put these two over each other. So 0.24 over 4.8 equals negative 0.05. Then we subtract that from 2.4, and since it's subtracting a negative number, we get 2.45. And then this becomes our second iteration. Now, f of x to the n is, if we plug that into our equation, we get 0.0025. Notice how these numbers are getting smaller. This number is getting smaller and closer to 0. We get 4.9. If we plug it into f prime, then if we put them over each other, we get 0.0005. Very, very small number. And when we subtract that from 0.45, we essentially get a number, a difference so small that it rounds to about the same value. Now, once you notice that, say you're given a certain number of decimals to round to, once you notice that it starts to stay the same, so 2.45 and 2.45, both your answers the same, that's when you can stop and assume the 0 is around 2.45. That is how you use Newton's method to approximate the zeros of a function. Now, if we were to plug this into a graphing utility, we would get the zeros to be, or at least one of the zeros, to be about 2.449. 9, we round, which is approximately 2.45.